We on? All right. So Jason and I co-ran a think tank about containers in the RDMA space. In the past, there's been feelings amongst some people, myself included, that maybe the RDMA space kind of missed the virtualization bandwagon. We didn't really have much support for what was necessary to do virtualization and get the RDMA devices into actual VMs. So we really don't want to miss the boat on the containerization stuff because there's a lot of good things that can happen there. So we had a lot of participation. We were really happy with that. Upstream community people were there, but more importantly, for me anyway, was the people that were there in terms of consumers of possible container technology. And we had some nice interaction between the people who were trying to design this stuff and the people that would need to use this stuff. It was kind of nice having Microsoft represented. We also had people from NASA Ames and some other places as well. It was actually a very good, constructive talk. By the way, this is going to go fast because a lot of this we know. All right, so the issue came up, what are the requirements people have for containers? Because it would have been nice if everybody said, well, we just need the kernel to provide kernel level ULP type RDMA access, and then you can just pump the rest of it and everything works. And nobody said that, so we didn't get off easy. So what they really want is they do want true multi-tenancy. Everybody wanted that. So they wanted the ability to make sure that a container was fully walled off from other containers and from the host itself. And we have to be able to provide an RDMA device inside that container that is fully contained and doesn't have any way of breaking out. There is a problem currently in that container orchestration mechanisms, whereas Kubernetes-based, Docker-based, whatever, they track things like CPU count, RAM amounts, and stuff like this. They don't really do much of anything else in terms of tracking. They don't track, for instance, specific RDMA devices, whether they're SRIOV-based or some other cloning creation that we make. They don't track that. There's no way of saying, give me a host that has this. So even just the infrastructure is not in place to support this. In order to make RDMA and containers work, we're going to have to add that infrastructure. But everybody wants that. So everybody wants the ability to say, this is my job. It needs this RDMA resource. And now find me a host inside of the entire catalog of hosts that can provide me the right resources. And that doesn't exist today. One last thing I want to touch on. And this was something that was primarily brought up by Microsoft in their Azure cloud stuff. And, this is an area where Microsoft was coming here specifically because they want to collaborate with the Linux community because the support for this doesn't exist today. And that's the device level enforcement of QoS for containerized RDMA resources. Because obviously, Microsoft's not going to be running the Linux host. They're only going to be running Linux containers and Linux clients. But they still want something that is programmable at the card level where they can tell the card, this host gets this amount of resources, this amount of bandwidth, whatever the case may be. That doesn't exist today for the RDMA devices. They know it's going to have to be created, and they were coming here specifically to talk to us about ways that we can collaborate and kind of do that in a joint fashion so that it's not reinventing the wheel for Linux and Microsoft, between the two operating systems. So it was nice to have that. So where are we now? You can actually create some containers, and you can put RDMA resources in them, especially if they're just kernel level provided RDMA resources, like access to the network via IPOIB, access to storage file systems like NFS RDMA, SRP, ISR, these kinds of things. These all happen at the host level, and the container only sees the results of it, the file system or whatever. That can work today. However, and you can actually create a constrained container using SRIOV and Rocky today.
Well, not for RDMA.
It should contain it some. An SRIOV device, separate GID. Shouldn't it work?
Yeah, okay, yep.
All right, but nothing else. Nothing else works today. Everything else has to be built. And so, what do we have to do? There's a long list of stuff to be done, actually. It's like, let's go reinvent the wheel all the way down. So The RDMA subsystem has heavily relied on sysfs files for configuration, as well as enumeration of devices and everything else. There's no good means right now to containerize these sysfs files because when you get right down to it, a particular container, all the containers need to see things like the GID table, but you only want a container to see their specific GID. So this is all done in a few sysfs files, but they're in the same directory. So we have to give everybody access to that directory and then only allow the container to read the specific GID file they're supposed to read. That's going to be a bit of a mess. We won't be able to use the kernel's sysfs container namespace stuff because it really walls things off and the containers won't be able to see necessary files. So we're going to have to do that ourselves internally because our model's messed up. We still have to finalize how we're actually going to do the namespace boundary. So like for instance, for an IB device, it's been tossed around using the idea of using lid, GID, and pkey as the tuple that defines a container space, right? It could work for some cards. It wouldn't work for other cards. That it can work on the Mellanox cards because they have a 128 GID table, so they've got enough room to actually have 128 containers there. On the other hand, you've got other cards, QIB and OPA, and you're not going to get that. They don't do multi-GIDs, so they've got one GID, and we'd have to do everything via pkeys, which means every single container would be on a different pkey, and that's not going to work. Some containers you want to actually be able to talk to each other. So we still have to come up with a solution for that. We don't have it today. Rocky v1 is just flat out. There's going to be no Rocky v1 in containers because by its very nature, the link local GID for Rocky v1 will break the containers because it totally bypasses all of the normal Ethernet constraint mechanisms, whether it's VLANs or other things. It goes straight to an Ether type header. So most of us thought it would be good to just preserve the current net device namespace semantics for Rocky and iWarp devices. There's been some discussion from Parav about doing it differently. We're going to discuss that, maybe somewhere upstream. And while we may use P keys for IB, we're going to use J keys for PSM. It's just going to have to be done differently because the hardware is different. We've also got some issues with IPOIB. Once you put IPOIB into a container and you do RDMA CM lookups, you get an...
Gets conflicts.
Yeah,
It becomes ambiguous.
Ambiguous, yeah. There you
problematic.
go. And so we're going to have to do all of this upstream. So the kind of the issue that Paul was asking about is where do we go from here? What's our path forward? Well, the path forward here is going to be upstream work. That's kind of how we always do this kind of stuff anyway at the kernel level. But at least we can say at this point we've got Mellanox devoting resources to it. I know Red Hat is going to be putting resources into it. So we've got some people that are going to be working on it upstream, working on the mailing list and everything else. So we'll be working that stuff. Personally, inside Red Hat, I'll be working on it, but I'm going to be coordinating and trying to bring in people from the Docker/Kubernetes space to help work on it too. So try to get some of that stuff in place. And that's us. Any questions? Oh, all right, yeah.
So our shiny new OFA mission statement says support, incubate, evangelize, whatever, advanced fabric technologies, of which RDMA is one. Mm-hmm. So the OFA has an obvious interest, or at least it should, in being sure that RDMA is supported everywhere, including containers. Mm-hmm. So I'm going to ask this question and make this offer, but it's not anywhere near as clear to me that it's appropriate in this environment as it was in the previous two. But we do have a structure and a framework. Would there be any benefit or anything that the OFA can do in terms of creating a framework or a structure or a format to help you work through these issues? The reason it's a little bit touchy is because the kernel community has its own way of doing things, and that's fine if that works for you. But I just want to make the offer. If there's anything that we can do that would help accelerate that, I think we'd stand ready to support that.
Okay. I'm sure that we can keep the current mailing list live so that people that want to talk specific container stuff, they can. But I haven't actually seen anything come through on the mailing list yet. Maybe everybody subscribed and then just went quiet.
Yeah, so our other mailing list.
Yeah. So, and like we said, we do a lot of stuff upstream, and we're going to continue upstream. So the best thing that I can see the OFA doing is helping with those situations where we might be able to outreach to other organizations. And so that's kind of what I'm talking about when I say internally at Red Hat, I'm going to be talking to the Docker Kubernetes people. That'll be with my OFA hat on, coming up to them and saying, listen, we want to make sure you guys support the RDMA stuff. So I know I'll be doing that personally, but other things the OFA could do in addition to that would be anytime OFA members are at other places where they could bring awareness, that kind of stuff.
Sounds good.
Any other questions? Go.
Yeah. So one of the biggest bottleneck we have today in RDMA stack is single-threaded RDMA CM. And with container, actually, scale is so important, and you don't want the RDMA, the CM connections across container to compete with each other. Is there a plan to address that? And because that's going to be a next challenge, actually, where containers will be competing in terms of connection management.
It's been brought up, but I don't know of a concrete plan to do anything or a concrete direction to improve RDMA CM's scalability at this point. Obviously, it's kind of at the bottom of that giant list Doug showed, because
It should be at top, I guess.
until you can get containers, you don't need them to scale.
Well, I spoke. Well, when I spoke to Parag off list, I think he gave me a hand wavy answer that most of the HPC guys do out of band connection management, but I guess as a community, it has been said that RDMA CM is the connection manager. So, a
lot of people say that, and then it seems quite a lot of other people just ignore that. So
it's not true.
Well, it should work better, and it should be more scalable so that it's applicable to more scenarios. I think mostly it's a resourcing kind of issue right now. It's a significant engineering effort to understand, what the bottlenecks are there and how to fix them. And maybe, who knows, maybe after Parav's finished making it work for containers, he'll have really good answers for you about where the bottlenecks are, because he'll hopefully understand a lot more of it than most of the rest of us do.
Yeah, I think the bottleneck, like we discussed this, is the single-threaded queue. I mean, it's the one guy who is going to line up all the...
That's regrettable, because the single-threaded queue is there to make everything work.
But it's not necessary for containers, that's what I'm saying. Containers are standalone. There is no serialization needed.
Perhaps you're right. There's a simple out there where we could have single-threaded queues per namespace.
Right.
Yeah,
And then that would work out. I actually don't know.
Sure.
that there's a lot of stuff that runs down that work queue, and it would all have to be audited, and it's all very tricky.
Okay.
But you're right. Yes, that might actually be really simple.
Thank you.
Bart.
Which use cases do you have in mind? Databases, MPI, storage of RDMA, or maybe all of them?
Okay, so Bart is asking, what use cases do we have in mind for containers? I think we talked about this during our workshop, or whatever we called it.
Yeah, the think tank.
The think tank, right, sorry. Basically, everything you can imagine under the sun can go into this model. One of the main motivating reasons to have containers at all is to manage your software stack, so that you have this application that's consistent of maybe hundreds of libraries and thousands of files, and it's distributed now inside of a container instead of as some sort of installable on top of some sort of distribution that all kind of has to be perfectly paired and is the exact opposite of what your other software needs on your same machine. So you could imagine your database is in a container. Web guys are doing that as a standard deployment now. It's a little bit harder to do like storage protocols like UOPs in containers.
Right.
We don't know how that's going to work out.
But like one of the big use cases would be the MPIs. I mean, I know
MPIs
I was involved with there was a spec created inside of Fedora specifically just for how do you package up an MPI, because we had to be able to put not only different MPIs on the same machine, but the same MPI, but different releases on the machine at the same time, and have them all operate properly. So it's actually kind of confusing, and it violates about 1,000 rules for packages that every other package on Fedora follows. And then so somebody comes in and takes a look at the MPI package on Fedora, and they're like, what kind of craziness is this? And then we point them to the spec for how you're supposed to package MPIs on Fedora. So a container would help solve that problem. You put your MPI in a container, there's no namespace conflicts with any other MPIs, but you can still have all of the different versions you need, and then you don't end up with things like the bug report I got the other day where somebody said, I installed OpenMPI and I ran MPI run and it went nowhere. There was no MPI run. I said, yeah, you got to load the module first because we support so many of them at the same time. So,
Right. So one of the use cases that was presented was kind of the opposite of what Santos was talking about, where the scale is intended to be exactly one container per host. And the only reason to use containers at all is essentially a way to boot an operating system really fast that has exactly what you want. It's a great idea, and it's solving a different problem than you're solving if you're worried about having 10,000 containers on your host and running concurrently. You're just worried about delivering software, not about managing microservices.
right. And then another one we talked about was getting completely outside of the HPC space entirely. But you talk about people that are building their own clouds, deploying their own clouds, all this kind of stuff. You've got your web server front end that's serving out some pages or whatever. A lot of times these have, back end communications between a web server microservice and a database microservice and everything else. Being able to put RDMA infrastructure on the backside and use the RDMA between the microservices, whether they're on the same host, different host, whatever, will help speed up the infrastructure. It just makes their cloud deployment considerably faster, just because of the fact that everything they need to use underneath the actual exposed layer to the world goes fast, much faster. I did some tests a long time ago, but even if you have two containers on the same host, if they're sitting there having to do communications across a virtual bridge and the CPU's copying data from container to container, it's horribly slow. You put an RDMA device in between there and have the containers talk to each other that way, it goes at PCI bus speed, and it's very fast. So that kind of thing provides a tremendous speed up. I was looking at like 5 or 6 times, it went from like 1.6 gigabytes to 10 gigabytes or something, I don't know. So anyway, much faster, and that kind of thing benefits people entirely outside the HPC space. So this helps us bring RDMA to other people.
So, sort of on the connection management side, we carry one of Bart's patches, which is a module parameter for setting the RDMA-C and timeout, affecting it sort of independent of the fabric. And so you can see that maybe with containers, you're going to have some issues around timeouts. And, we see this with, fabric instability issues, slow receivers and things like that. So timeouts might be.
So you want to see various configurables namespace too, or at least isolated to the device if they're globals today. Yeah, that makes sense.
Well, if we end up punting and doing a work queue thread per namespace, then you can set that timeout per thread.
I don't remember how all that works. I think it's delayed work. I don't know. Yes.
So for traffic
Right.
classes, I mean, really, need some
Well,
more work in those.
traffic class or namespace or device, or those are easier to identify in the kernel. It's a bit harder to identify traffic class.
Yeah. All right. Okay.
Anything else? Going once, going twice? Thank you, Container Think Tank.